Today's lesson, Unit 7, Lesson 8, Combining Bases. Our learning target for today, I can use and explain a rule for multiplying terms that have different bases but the same exponent. Please open up your workbook to page 42. If you don't have your workbook, that's okay. You can still follow along. Page 42 in your illustrative math workbook. So what happens when you want to multiply two expressions with two different bases, but the same exponents? Remember, in the expression, b to the a power, the b is the base, and the a is the exponent. So if we have this chart, it says complete the table to see how we can rewrite expressions with different bases and the same exponent. So when we're talking about the same exponent and different bases, so remember our bases are, in this case, would be 5 and 2. And our exponents would be 3 and 3. So what we're practicing today is when we're talking about when we have different bases, but the same exact exponent. So let's do a few of these together, and then you can pause the video and we'll go over the answers shortly. So if in our expression, 5 to the third times 5 to the third times 2 to the third. So if we did this in expanded form, what this is saying, 5 to the third means 5 times itself 3 times. So 3 factors of 5. 5 times 5 times 5. 1, 2, 3. This one, 2 to the third means we're going to multiply 2 times itself 3 times. So 3 factors of 2. 1, 2, 3. So if we would, what we're able to do here, we can rearrange the factors in the original multiplication expression. So what that means, I can take a factor of 5 and a factor of 2 and combine them. So I could say 2 times 5, 2 times 5, and 2 times 5. So I'm taking a factor of 2 and a factor of 5 and combining it into a multiplication. And I have that 3 times. So I'm using a 2 and a 5, a 2 and a 5, and a 2 and a 5. So what we can do from this, we can multiply this out. Well, 2 times 5 is 10. So it's be 10 times 10 times 10. And 10 times 10 times 10, or 10 times itself 3 times, is 10 to the third. So that's what we're looking for you to do to fill in this chart. It's going to get a little bit more difficult as you go down, but we'd like you to pause the video and try filling in as much as you can. Alright, so let's start working on these. So if we're working on expanded form of the expression 3 to the second power times 7 to the second power, and what that would look like is 3 times 3, and then 7 times 7. And when I want to rearrange these, I want to take a factor, 1 factor 3 and 1 factor 7 and combine them. So 3 times 7, and do it again, 3 times 7. Notice I'm going to have two groups, because that's telling us our exponent is 2. So 3 times 7 is 21, 3 times 7 is 21. So 21 times 21 is, with the exponent form, is 21 to the second power, or 21 squared. Our next one, we need to fill in the expanded form and the exponent form. So our expression is 2 to the fourth times 3 to the fourth. So that means we're going to say 2 times itself 4 times, 1, 2, 3, 4, and then times 3 times itself 4 times. 3 times itself 4 times. 1, 2, 3, 4. Now I'm going to rearrange. I'm going to take a factor of 2 and a factor of 3, and I'm going to do that 4 times. 2 times 3, 2 times 3, 2 times 3, 2 times 3. Well, 2 times 3 is 6, so it's going to be 6 times 6 times 6 times 6. That's where this is coming up. And this would be 6 to the 1, 2, 3, 4. 6 to the fourth power. Our next one, we need to do the expanded form and the expressions. We kind of got to work backwards, but that's okay. So we have 15 to the third power. So what we need to do is come up with factors that work with 15, so 3 and 5. So in this case, they're telling us it has to be a factor of 3. I'm sorry, as an exponent of 3. So I want to use 5 times 3 is 15, so it's going to be 5 times 5 times 5, 3 times, it tells us, and 3 times 3 times 3, 3 times because of the exponent of 3. And if I rearrange, I took a factor of both, combine them, 3 times 5, 5 times 3, and 5 times 3, and we do that 3 times. Because 5 times 3 is 15, so 15 times 15 times 15, that's where this comes, and 15, since there's 3 of them, it'd be 15 to the 3rd power. Now if we're going back even further, this should tell us it's going to be 5 to the 1, 2, 3 power, 5 to the 3rd power times 3 to the 3rd power. All right, so that's how we work backwards. We're going to do the same thing for 30 to the 4th power. So this one, you're going to pick any number. So your answer might be a little bit different depending on what numbers you use that multiply into 30. So I want to use 6 and 5. So pick any factors of 30. So possible answer. Here's one. So they're saying 30 to the 4th power. So that means it's going to be 30 times 30 times 30 times 30. And what do we, that's to be to the 3rd power. So if I'm going to go truly backwards, what two numbers multiplied together will equal 30? Well, 6 times 5. And I have to do that 4 times because it's our exponent of 4. And we have 4 factors of 30. Then if I wanted to organize these by putting all the 6's together and all the 5's together, there are 1, 2, 3, 4 6's. 1, 2, 3, 4. And there's 1, 2, 3, 4, 5. So there's 1, 2, 3, 4, 5's. And then we're going to go back. So that should be 6 to the 4th power times 5 to the 4th power. If you notice, each one of these, they all have the same exponent. Different bases, but same exponent. All right, so this one we're using one with a variable. We're going to treat it the same way. This is 2 to the 4th power times x to the 4th power. So if we're going to write these out, it would be 2 times 2 times 2 times 2. So 2 times itself 4 times, and then it's going to be x times itself 4 times. So that's what this would look like. And if I'm going to rearrange, so I'm going to take a factor of x and a 2, multiply them together, so it'll be 2 times x, 2 times x, 2 times x, and 2 times x. We should have 4 groupings like that because it's to the 4th power. 2 times x is 2x, so it's going to be 2x times 2x times 2x times 2x. And that's what shows this. And our last exponent form answer, it would be in parentheses 2x to the 4th power because there's 1, 2, 3, 4. Moving on to one that has 2 variables with n as our exponents. So this is going to look a little bit different, being that we don't know what n is. So we know that's going to be a times itself. We don't know how many times. That's what this dot 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 means, times a. And we knew the same thing for b. We don't know how many times because n is just the exponent. So b times however many times b. If I rearrange these, it would be a times b. We don't know how many times we're doing that. So to write this, we're going to write it as a times b in parentheses, all to the nth power. And our last one, this time we have 3 different bases, but they all have the same exponents. So we're going to treat it the same way. We're going to have 7 times itself 4 times, then 2 times itself 4 times, and 5 times itself 4 times. That's what this shows. Now we're going to take a factor of each. So we're going to take 7 times 2 times 5, and we're going to do that 4 times. 1 set, 2 set. There should be one more set in here. There should be 4 sets. And there's only 3 here, but there should be 4. And so it's going to be 70 times 70, because 5 times 2 is 10, 10 times 7 is 70. So 70 times 70 times 70 times 70. So we have 4 70s, so it's going to be 70 to the 4th power. All right. There's our completed chart. So what's the new rule? So multiplication problems with expressions that contain different bases with the same exponents can be simplified by multiplying the two bases together and then keeping the original exponent. So this only works when you have the same exponents with different bases. So here's an example. If we had a to the nth power times b to the nth power, notice we have the same exact exponents, but we have different bases. One's a, one's b. So we're going to multiply a and b, and we're going to keep it all to the same nth power. So let's look at these. So what about an expression with different bases and different exponents? So if we have this problem, 7 to the third power times 5 to the sixth power. Will this work? No, if the exponents are not the same. So we have different exponents. The factors cannot be grouped together evenly. So this cannot be simplified using this rule. So the rule that we just spoke about, multiplication problems with expressions that contain different bases but with the same exponents, this can be simplified. So by multiplying the two bases together and then keeping the original exponent. All right, so let's simplify the following expressions here. So if we did this, notice we have different bases, same exponent. So our rule was we're going to multiply our bases, 5 times 7, and we're going to keep our exponent. So 5 times 7 is 35, and keep it with our exponent 6. Next problem, 3 to the fourth power times 5 to the fourth power. Different bases, 3 and 5, but the same exponents. So we're going to multiply our bases, 3 times 5 is 15, and keep our exponent of 4. Next problem, 6 to the third times x to the third. Different bases, same exponent. We're going to multiply these, so it's 6x all to the third power. One to the ninth times 15 to the ninth. Different bases, same exponents. So 1 times 15 is 15, and we keep our exponent of 9. 15 to the ninth power. So let's review evaluating. So evaluating the expression, remember, evaluate means to actually solve the problem. So the answer won't have any exponents. So here we go. Take a moment, pause the video, and solve these. All right, so we have 8 to the second power. That means it's 8 times 8 is 64. 2 to the fourth power. That means we're going to multiply 2 times itself 4 times. 2 times 2 times 2 times 2 is 16. 10 to the third power. That means we're going to multiply 10 to it times itself 3 times. 10 times 10 times 10 is 1,000. 3 to the 0 power. Anything to the 0 power is going to equal 1. 1 to the 6th power. That means 1 times itself 6 times. 1 times 1 times 1 times 1 times 1 times 1 equals 1. And our last one, 3/4 to the second power. So we're going to multiply 3/4 times 3/4. 3 times 3 is 9. 4 times 4 is 16. So our answer is 9/16. So let's put it all together. Use our exponent properties to simplify the expression. Then evaluate. Remember, evaluate means to solve the problem, so the answer won't have an expression. So pause the video, try these 6 problems. All right, 4/5 to the second power. That means 4/5 times 4/5 would be, so 4 times 4 is 16. 5 times 5 is 25. 16/25. Moving on. This one, in our rules, we have the same base, but different, we're multiplying, so we're going to add our exponents. -3 plus 3 is 0, so 10 to the 0 power, which equals 1. This rule, powers to power, that means we're going to multiply. 3 times 4 is 12, so 2 to the 12th power. If you needed the calculator, feel free to do that. If you need a review on how to put that into your calculator, please let us know. 2 to the 12th power, that means 2 times itself 12 times, will be 4,096. 2 to the -5th power. So being that it's a negative exponent, we're going to put it in as a fraction. It'll be 1/2 times itself 5 times. Or, I'm sorry, 1 over 2 to the 5th power, and we're going to do that 5 times. So 2 to the 5th power is 2 times itself 5 times, which is 32. So it's 1 over 32. 7 to the 4th over 7 to the 4th. We're going to subtract our exponents. We have the same base. 4 minus 4 is 0. So it'll be 7 to the 0 power, which equals 1. And our last one, since we're multiplying, we're going to add our exponents. 5 plus -7 would be -2. 7 to the -2nd, which we need to make into a positive. To make it positive, we're going to take the reciprocal, so it'll be 1 over 7 to the 2nd power. And to solve this, 1 will carry over as our numerator. 7 squared, or 7 times 7 is 49, so 1/49. So that's it for today. So head on over to Schoology for today's practice. Email me if you have any questions.